My name's Peter Taylor. I'm a professor at the University of Melbourne, and I'm the director of ACEMS. And it's my pleasure to be hosting this public lecture today on disinformation online, social networks and mathematics. Before we start, I'd like to acknowledge the traditional owners of the land on which I sit, which is the Wurundjeri people of the Kulin Nation, who have been custodians of the land for thousands of years. And I'd like to pay my respects to their elders past, present and emerging. And I'd also like to acknowledge the original owners of all the lands where other people listening to this seminar around Australia and indeed around the rest of the world. And I'd like to acknowledge the owners of those of that land as well. So our speaker today is Associate Professor Lewis Mitchell. Lewis is at the University of Adelaide. He's a Chief Investigator of ACEMS, and he's very well known for his work in analysing various things to do with social networks, and in particular, you know, how we understand what's actually what sort of trends are happening. And as you see from the title of this talk, it looks like it's going to be a very, very interesting exposition on what we can and can't and should and shouldn't learn from social networks. So Lewis, I'll hand over to you. I'd just like to say that if anyone's got any questions, if they could put them in the Q&A, and then we'll deal with them at the end of the lecture. So thanks, Lewis.
Thank you, Peter, and thank you everyone for being here. I'm standing in a room with some actual people in front of me, with the beautiful city of Adelaide in the background. So it's wonderful to be talking to you and all of you online. So I'm going to talk about misinformation, disinformation. You know, the underlying theme is going to be information and online social networks. And I'm going to try and tease out some of the ways in which we use mathematics to actually understand the fundamental processes that are going on with these things. There's a cast of thousands of collaborators there that appear at various times through this talk. I want to start with actually showing some of the student team that are on board at the moment. So it's not all of them, but these people are my research community, and you know, I really stand on their shoulders to be talking here about this stuff today. So I'm extraordinarily thankful to all of these people. I'll call out a couple of people here. So Bridget Smart, who's just started a master's on online social influence. And Tobin South, who's a recent master's graduate, is about to go off to MIT on a Fulbright scholarship and is now an ACEMS research assistant. They jumped in at the last minute to help out with creating some figures that you'll see later on in this talk. So you know, I'm particularly thankful to them. Okay, so you don't really need me to motivate misinformation and disinformation for you and why it's important. You know, over the past few years, misinformation and disinformation, whatever those terms mean, has been on the rise, and particularly in the last year or so, since the start of the pandemic, you see that there has been an increasing level of concern about misinformation and disinformation. It's even spawned this new phrase, an infodemic, which didn't exist before. So, you know, just as we have the pandemic raging, so there is considered to be a corresponding information epidemic of bad information. So it bears pointing out that misinformation and disinformation pale in comparison to fake news, which appeared suddenly out of nowhere towards the end of 2016, is here and has persisted ever since. You know, you can probably figure out why that is. You know, hopefully that's, you know, it's maybe on the decline. But this is a clear and present concern, you know, for nations around the world. You know, it's such a concern in the past year or so that the World Health Organization, you know, has coined this new phrase infodemiology, and is so concerned about the infodemic, you know, the pandemic of bad information, that they're actually calling for research on, you know, what they're establishing as this new field of infodemiology. So this is really important stuff, and I can give you case study after case study from the past year of where misinformation, disinformation, fake news, the infodemic has impacted all of our lives. I'll actually go back a little bit in time to give you a case study here. So before the pandemic started, approximately 15 years ago, we had a bad bushfire season in Australia, and there was a concern at that time that there was a disinformation campaign being propagated on social media, where people were claiming and pushing a false narrative that that the bushfires were started by arsonists rather than by climate change. So that was an article from The Guardian. You see that the ABC News talks about misinformation being spread through social media, with Twitter and Facebook being the main culprits. And so you notice there's disinformation and misinformation there. So we need to disentangle those, which we'll do in just a sec. But social media has largely been considered to be a culprit or a spreader of this sort of bad information. So here's an example of one of these toxic tweets. This was the idea in the bushfires, is that arsonists started the fires. This is actually being tweeted at Alexandria Ocasio-Cortez, the US Congresswoman. So this is reaching the highest levels of the US government in some sense. It's a very strange, pervasive form of misinformation. So we actually took a look at this, and by we, I largely mean Derek Webber and Marwish Nassim. So we took a look at some of these tweets about bushfire misinformation, about this arson emergency sort of meme, or this piece of misinformation. And we looked at various things, including what role do social networks play. So one interesting finding from this study was that if you look at the people who share the same information on the one side about the arson narrative and on the other side about the climate narrative, you see these strongly polarized communities where the arson narrative propagates in one community, and the climate narrative propagates in another community, and they're highly segregated. So it's clear that social networks are playing a role here, right? In terms of this information going viral or propagating, there's a clear effect of network structure. So the question of misinformation and disinformation is fundamentally tied to understanding the social networks on which those dynamics are propagating. So that's one thing, that'll be one theme of this talk. Now, I've talked about misinformation and disinformation, and it's in the title of my talk, without distinguishing between those two things. There are actually a lot of different terms that we could talk about here, but just to pick on these two, essentially the idea of misinformation is that it's stuff that's not correct, right? So it's wrong information. It is wrong that arsonists were responsible for starting the bushfires. It is wrong that if you drink drink bleach, it will cure you of COVID-19. That is different to disinformation, which is stuff that is incorrect, and it is designed to deceive or dissuade you from some prior belief. So there is some sort of intent behind disinformation. So that's a sort of subtle but important distinction when you're thinking about these these things. But a point that I want to try and draw out in this talk is that fundamentally, both of these and all forms of fake news, infodemic things like this, the fundamental process that's going on as this stuff is getting propagated online is an information flow question. So fundamentally, if we want to understand the governing processes behind misinformation and disinformation or fake news or whatever we want to talk about, we have to understand the dynamics of information flow. So there's a role already, there's a huge role for mathematics in here. If we want to really try and understand, map and predict how these infodemics propagate, we need physics of the underlying information flow, or in other words, we need mathematical models, and this is where we'll be getting to today. So there's kind of three different levels in my mind at which we can talk about information, and the way that we can talk about information flows. So in many ways, the most important level at which to think about information is at the level of facts, right? At the level of a piece of information is a fact, or it is something that is true or is false. As a piece of true information or a piece of false information, misinformation or disinformation, and it's something that we can, ascribe some human meaning to. So there's some work on studying information at that level. So here's a very large-scale study from just last year, I believe, led by a very famous complex systems scientist and Australian graduate of the University of Melbourne, Duncan Watts. And what they did in this study is they actually looked at the types of information that Americans consume at the level of what they call the information ecosystem. So looking at online, looking at TV, looking at radio, looking at all the different, looking at social media, looking at all the different forms of information that people consume. So this is a very large Nielsen survey result with over 100,000 participants in it. And people looked at the types of information that people consume. The interesting thing that you notice is that across all these age brackets, the red little bars here are the websites that are fake news websites. So they're promoting not real news. They're promoting literally fake news, and so it's a very small percentage of the information that people consume. The other aspect of that is that the top panel is just looking at online consumption, and you see the red line at 20% here, or 20 minutes per day of consumption of online media, of which a small proportion is fake news. You compare that with television news consumption by age, and you see that fake news is actually a really small proportion of what Americans are consuming, and it's completely overwhelmed by television news in various and television media. There is a sort of caveat here in that the right panels are looking at news media. If you look at social media, if you look at people sharing information and spending time on social media, on Twitter and Facebook and the like, then you see that the average number of minutes per day that Americans are spending on social media is 60 minutes. So it's up here with the largest amount of television news or television media that people are consuming. So, there's a couple of points to make. Fake news might be small, or truly identifiable fake news might be small, but it might also be noxious. And social media is clearly, again, is clearly a big theme here. It's really something that we need to delve into and understand. There's another great study, which is a couple of years earlier, that's Twitter specific, about the spread of true and false news online. And what they did in this is they looked at retweet cascades. So they looked at things that were verified to be true and things that were verified to be false. So in this study, they used websites like Snopes, which is a fact-checking website, PolitiFact, a political fact-checking website, and 4 or 5 others. And they looked at tweets that talked about fake news and tweets that talked about real news, things that were verified to be true. And they looked at how far fake news and real news spreads, and how fast, how deep it spreads through the social network, and how broadly. And these figures show, there's a snapshot of some figures from the article, which I don't need to explain in any great detail, because the underlying message, the quote, the key headline from that article is that false news, lies spread farther, faster, deeper, and more broadly than the truth. Right, so it takes a long time to fact check stuff, and misinformation, disinformation, fake news spreads more like wildfire. It is more attractive for people to share on for various reasons, and it is just more successful at spreading fast and wide. So they're two key studies in this area, and they really tackle the problem that we want to ultimately look at, which is fake news, fake information versus true information. It's at that human level of what we understand information to mean. So these studies are really important because they focus directly on the human level problem, right? The problem with studies like this is that they're incredibly costly and they're time consuming. The first study involved a Nielsen study of 100,000 plus people. So that's a huge, large scale, expensive, difficult to manage study. The second one involves verifying things as being true or false from various different websites. So all the effort that's gone into doing the fact checking on Snopes.com or on PolitiFact.com is part of the process of doing that kind of study. So these are really difficult methods to scale or to use in real time. It's not impossible to do that. You could imagine training some machine learning algorithms to try and predict these things or try to look at the truthiness or the falsiness of tweets or Facebook posts in real time, but you still have to train on something, right? Like you still have the investiture of time in doing the fact checking at the very least. So this is incredibly difficult to scale and is a big problem. That's the top layer. That's the most important layer. At the other end of the spectrum, information to a mathematician like myself means Shannon entropy and is something means information theory that has been around since the 1940s. It's talking about information at the level of ones and zeros, right? To mathematicians and computer scientists, when we talk about information, we mean strings of bits. So you could analyze information online at a purely fundamental base level where you talk about the ones and zeros that have been propagated by people and analyze all of that data. It's a huge data problem. There's 60 years, 70 years of mathematical theory around that, but it doesn't capture the thing that we want to capture, right? There's no distinction between good ones and zeros and bad ones and zeros here. So that's also a level that's not entirely useful to us. What we need is a sort of a middle level, which is at the level of talking about words or phrases or messages or posts. So the basic modern unit of information is not so much a 1 or a 0. It's not at that level of the network structure of the internet. A unit of information is a post, right? Or it is a tweet, or it is a word, or it is a sentence. And so that's the level at which people are starting to work at. It allows you to use a mathematical modeling and a rich statistical toolkit. Because I'm going to focus on this layer at this level for the rest of the talk, and I'll talk in more detail about some of those tools. But there are issues as well, which is that at this level, we tend to use proxies for information, right? We don't actually talk about words and phrases and messages. We tend to focus on things that are easy to count and easy to measure. So what do I mean by that? Here's another great piece of work. Also by an Australian, or a group of Australians here, particularly Tim Graham from QUT. There's a whole industry of looking at coordinated activity networks. So what you see on the right is a Twitter network again. So it's people sharing posts about COVID-19. And there are edges, so people are connected in this network if they tweet the same stuff at the same, roughly the same time. So if people are coordinating, if they're in the sense that they're tweeting at the same time, we put edges between them and they become connected, and you see these clusters emerge. And the thing that you notice, or the great thing that Tim and these other researchers are noticing, is that firstly there are these signatures of these coordinated activity networks, and they can be linked to bot behavior. So the red clusters are very bot-like accounts. So that's really interesting. But the key piece of data that's being used there are these timings of posts, right? So it's not the content. There's nothing about the content of the tweets in here. There's no words or phrases, just timings that are used at this level. So that's a proxy for some sort of information. There are more sophisticated things that you can do. So I'll call out another recent ACEMS graduate, Caitlin Gray. You can do more sophisticated things where you can look at retweet cascades. So you can look at cascades of people sharing these messages, and you can reconstruct networks using Bayesian techniques. And this is one of the great themes of ACEMS, is doing this sort of study. You can actually reconstruct very sophisticated networks of cascades of influence or information flow. Again, the data that gets used there is, did this person share on a message? It is, did you retweet this tweet? And again, it doesn't look at the content of the tweet. So that at this level at which we want to actually work, the level of words, the level of individual posts, this sort of mesoscale and this 3 levels of information. We often resort, the paradigm is often to resort to these proxies, and we resort to proxies, timings of tweets or flags showing that we've retweeted another message. A lot of the time because they're easy to measure, right? And because they're easy to count, and that's a very sensible thing to do. But ideally, we would like to use more of the information, more of the data that is available to us, right? From Twitter or from Reddit or from many of these social media platforms, I can download an entire person's history. I can see every word they've written, and I can look at every image they've posted over time. We can analyze all of that data. So that's an opportunity for us to actually delve deeper into these data sets and to use more of the data that's available to us to actually measure information flows and influence. So yeah, so this is the question for the remainder of the talk, and this is the segue into my own research. How can we use the full extent of the information that is available in social media data rather than proxies? And so by the full extent of information, I mean the words, I mean the things that people have written. So okay, so here's where we get to the the reason behind the misdisinformation. Fundamentally, we're talking about information. And fundamentally, we're talking about words. And so this is what I'm going to talk about. So we've got 3 short things to talk about: measuring information flows, and then how to map information flows at this level of words. And then I'll briefly talk about some models that we can use. So how do we measure information flows at the level of words and phrases and the actual content of things that people talk about? So there's a rich literature on this again. We don't have to entirely reinvent the wheel. There are things called entropy estimators here, which actually, I could talk about in detail about how this mathematics works, but I don't want to put too many equations in the talk. So I'm conscious that every time you put an equation in, you lose half your audience. So for the people who are remaining, you don't need to understand that equation. It is trying to describe how many bits of the fundamental unit of information, how many bits are needed to describe somebody's next word given their past word. So if I download everything that Peter Taylor has written in his emails, I could use that to build a model to predict Peter's next word. And it might not, we could think about how good that model might be. And these entropy estimators that you see there are a way of estimating that. If you take for granted that you can do that, there are good mathematical ways to do that. You can start to talk about predictability. So you can start to talk about how predictable is Peter from the last, how predictable is Peter's next word from the last words he's written. So what's the probability of getting Peter's next word correct? Again, another equation, I've lost another half of the audience, so we're down to 25%. But a predictability here means a probability of predicting the next word correct. And the way that this works is that if you measure this entropy rate from data, which you can do, you can convert it into a measure of predictability. Here are some examples of those entropy estimators applied to, not to tweets or anything or emails, but to literature. So, for whom the bell tolls, as Hemingway uses sort of sparse language, right? So his entropy is relatively low and the predictability is relatively high, therefore. Lord of the Rings is much more complicated, larger cast of characters, more complicated storylines. You know, this the 7.07 here explains, well, I'll never get past page 19 of James Joyce's Ulysses, and I now have empirical data to back that up, because why would you read a book that has an entropy of over 7 bits per word? It's just madness, and it's really too difficult to do for me. Okay, so we did an experiment with these. We didn't look at books. We looked at social media data. Essentially, we collected data from a lot of Twitter users, and then we wanted to look at their friends. We wanted to look at how much we could predict somebody's next word from the information that's in their friends. So in other words, if Peter writes lots of emails and Peter sends me lots of emails and we interact backwards and forwards, how much can you predict about me by reading Peter's, having hacked Peter's emails? You know, or if Peter was on Twitter, then I'd use that example on Twitter. But you know, we looked at this by looking at people's tweets, and how much can you predict about an individual from their friends, from their closest 15 friends in this case. So to do this, we had to invent a new entropy measure, so a way of generalizing that idea of predicting somebody's next word from their past. But we looked across all of these friends now. So instead of trying to predict Peter's next word from Peter's previous words, you look at trying to predict my next word from Peter's previous words, and, you know, and everybody that is in my email network or in my social networks, how much they say about me. So there are lots of fancy pictures there. The most important picture to focus on is this one, where what we did is we agglomerated, or we accumulated, the number of friends that we were looking at. So along the x-axis here, the horizontal axis, if you look at somebody's closest friend, their closest 2 friends, their closest 3 friends, all the way up to 15, how well can you predict the individual themselves? So if you were reading the person's, if you had access to the person's tweets, you would be able to achieve this level of predictability. That's the horizontal line here. And the amazing thing that we notice is that by the time you've gotten to 8 or 9 friends, you can do as well at predicting the person in the center of that circle as if you were reading their tweets themselves. So in other words, if you delete your account from Facebook, but all your friends remain on Facebook, Facebook can still make predictions about you in principle from your closest 8 or 9 friends. So, you know, a few years ago, there was a craze for people to delete their account on Facebook in the light of the Cambridge Analytica scandal. And the sad message of this research was that it doesn't matter, right? As long as your friends don't delete their account, predictions can still be made in principle about you. And that's coming from the words that people write, from all of the information that we have available. So that's kind of a downer. So let's start to think, is there something more constructive that we can do, and talk a little bit about mapping information flows. So here, the data set that we're looking at is much more contemporary. You know, it comes from the 2016 elections. So a thing that Twitter does periodically when they detect information operations, sort of influence campaigns or fake news campaigns happening on social media, is that they take down all the accounts and they publish them. So they did this in the 2016 US election around the Internet Research Agency, which is a bunch of trolls that were spreading misinformation. There are lots of studies that got done on this data set, including by 538, and they found that these trolls were not all the same, that they mimicked different types of US actors. So they mimic people on the left, they mimic people on the right, they mimic news websites, and then they had some coordinated activity bot-like accounts where they tried to glom onto trending topics. So we had some questions about this. Was how should we best measure this coordination? And I've talked about a timing-based approach earlier when I talked about coordinated activities, but I've also just introduced this content-based approach where we actually look at the words and look at how much information is shared between individuals. And then we want to understand, do these trolls actually have any influence, and can we map this? So here's a figure that Bridget made using Tim Graham's coordinated activity approach on this Internet Research Agency data set. You've got all of, there's each dot, each node is a different Twitter account, and there are lines, there are edges between these nodes if they shared the same piece of content within a short time window. So they coordinated in that time sense. Let's zoom in a little bit, and you can see that these bot-like these hashtag gaming accounts have quite a large coordinated activity network. There are also these red accounts that are imitating right-wing actors, right-wing people. They're quite small there. So that's what the coordinated activity network shows you. The other perspective is to actually look at the information flows. So using this idea of predicting the next word from a friend, you can actually build a network, or you can actually build this map of information flows between all of these different accounts. So this is what Tobin did using this code to implement these algorithms that I talked about earlier. And the amazing thing that you notice here is that the right-wing trolls actually have, if you look down in the bottom left, they actually have a lot of information flowing from them to these other actors in the network. So to these other fake accounts, it's almost like, here's a more aggregated version of this. It's almost like the right-wing trolls are sort of being thought leaders, they're proposing new ideas, and then that's getting bundled into that's getting copied in this fake discussion that's coming on, that's happening, and it's filtering into things like these news feeds as you go on. It's almost like there is some level of influence just between these fake actors. So that's really interesting, and it shows you something different to what you see using these coordinated activity approaches. So it's just one example of what I think are really potentially powerful things that we can do by actually looking at the full content that's available. So there are some observations about this, and there are some open questions on this part of the research. And I should emphasize that this stuff is stuff that we're working on now, so it's very much in process. So I've had this theme. I've been talking about how these proxies, timings of posts and flags saying sharing retweets and things, there's not true influence, it's not true information flow. And so actually looking at the content of what people write and trying to measure whether we can quantify that copying of phrases and of tweets and of words and of things, this actually tells us something that's quantitatively new, that's quantitatively different about social networks. So, for example, you wouldn't have seen, by looking at the pure coordinated activity approach, you could not have constructed these hypotheses for directions of influence here, or directions of information flow between these different types of accounts. So, this gives us a possible way to explore influence online beyond just these coordinating networks. So if we're thinking about misinformation, the propagation of fake news or misinformation or disinformation, we can actually look at the content of those posts and look at how it propagates, or measure and map how it propagates without having to use proxies, without having to make assumptions, or without having to laboriously necessarily go through and fact check everything. So the thing that jumps out to me as a kind of data scientist and network scientist from these pictures is that clearly, as I alluded to right at the start of the talk, this network structure is really important. But it raises a new question for us, which is, what's the network that we're really talking about here? I can construct networks in lots of different ways. So through coordinated activity on different types of posts, through information flows, through retweet cascades. There are all these different options and all these different perspectives of these social networks. You have the follower network, the reply network, all of these different types of networks. And so studying all of those different networks concurrently or in tandem is a really powerful thing for us to do and shed some new insights. And everything that I've talked about here is a data-driven approach. right? So everything that we've talked about so far takes some data, creates some summary statistics of it, and then shows us interesting patterns. But the question that we have as applied mathematicians, or if we want to do something more predictive, is we want to try and model this behavior, right? If we actually want to understand the physics and science of what's going on with this information propagation, we need models. So, okay, so let's briefly, in the last 10 minutes or so, let's talk about how to model these information flows. So I'll tell you what the state of the art is here. I'll introduce one more new idea that's sort of motivated by this theme that I have of looking at the words and looking at the actual content of what people write. So here's the state of the art in many ways for modeling an infodemic. So the picture here is of an SIR model. It's very it's the Newtonian mechanics of epidemiology. Really, you might have heard about it over the past year because we've been living through a pandemic. And the idea of the SIR model is that you have individuals who start out as being S for susceptible. If they get infected, if they come into contact with somebody who has the disease, they become infected. And then they stay infectious for some period of time, and they become recovered or removed from the population eventually. You can write down systems of differential equations to model these. You can write down stochastic models for these. But the essential idea is that you have people coming in contact with each other, transitioning from susceptible to infected to recovered. That's how we have modeled the COVID-19 pandemic and every pandemic before, essentially. With lots of complexity added. There's two types of things that you can do here. So the first idea with this SIR type model is simple contagion. So basically your probability of transferring from being susceptible to infected is just proportional to how many people you come in contact with who are infected. So how many of your neighbors or your friends are infected. Now for a disease, for an epidemiological disease, it makes sense that should just go up, right? So the more people you come in contact with, you're just more likely to get infected yourself, right? So that's a simple idea. The other idea, and the way that this applies to information contagion, so the way that this is used to model information flows, is an idea of complex contagion. And so the idea in that is that your probability of becoming infected only jumps up from 0 if a certain fraction of your neighbors are infected, right? So if Peter sends me some fake phishing email, I'm not going to be, well, I would be probably quite likely to click on it because that would be quite unusual. But just one of my friends sent me some piece of misinformation, I'm probably going to ignore it. But if 10% or 15 or 20% of my friends start bombarding me with this same meme, well, I'm likely to start to look at it. Then it's going to get over the threshold for me, starting to want to share that on myself. So I might become infected then. So these different assumptions, these simple contagion and complex contagion assumptions, lead to very different types of behavior. So on the horizontal axis here, and this is for this simple contagion, we're looking, we're simulating these models on a network, so where people come into some contact, exist in some contact network. And as you go along the horizontal axis, that network's getting denser, there are just more connections between people, they're social distancing less. And so the peak size, the size of the epidemic just goes up, right? As people come in contact more, the peak size of the outbreak gets larger. That makes sense. In this complex contagion, you get something that's kind of counterintuitive. It's kind of like a hipster effect. So as you get more and more friends, it becomes more and more difficult to infect a large fraction of them. And so the denser the network gets, people tend to sort of switch off, right? You can't actually propagate these memes as easily, and so the peak sizes drop down. And so that's, that drop, that non-linearity there is the characteristic feature of this complex contagion, and it's the way that people use to model information flows. Here are some issues with that. You know, it's not clear that that's a realistic model for information flow and the complex contagion idea. And these don't model anything about how people generate information, right? We have to invent this, you know, what we call social reinforcement function here to get these models to work. You have to propose something out of thin air for how, for the probability of becoming infected from your neighbors. And there's no theory on how to actually choose those things. Yeah, and you know, most importantly for me is that information, you know, here is means are you infected or not, right? Have you spread the meme or have you not? And so again, we're using a proxy. We're not talking about anything about the actual content of what people are writing or are talking about. And you know, yeah. So this should be able to be informed by data. So here's a suggestion. Here's a proposal for a model that one could use instead. So it's very much motivated by these information flow ideas as I've been talking about. And it actually tries to model people actually spitting out words. So people actually write out words and then they look at their neighbors and with some probability they copy, you know, they retweet, they actually pass on this piece of information. So it's kind of, it's a simple sort of stochastic, almost agent-based model type idea for people who are into those sorts of things. And it's a, you know, it's a model that you can use that actually tries to characterize some information generating process. So it actually talks about words. My final result slide here is that the amazing thing about this model is that it actually produces the same type of characteristics as this complex contagion. So without the need for this wacky social reinforcement function, we actually see the sorts of dynamics or the sorts of behavior, this decrease here as you get in these complex contagion models. So it's possible that that's a path forward for actually explaining why you should choose some type of modeling approach over another, or actually producing a more realistic information flow type model that actually looks at content and looks at words. So that's it. So yeah, it captures this complex contagion-like behavior. That's it. So a quick summary here. The themes of this talk overall, misinformation, disinformation, all of this stuff is clearly a clear and present danger, right? This is not going anywhere in the age of social media, and it is of concern for us to study. I've talked about a lot of different ideas in a sort of survey here, but the important theme about everything I've talked about here is that the underlying physics of this process, you know, the Newtonian mechanics of misinformation flow is mathematical models, right? So it's information theory. I've hopefully convinced you that the network structure plays a really important role. So network science and data science are important. And these stochastic models, like this quota model, if we actually want to predict or actually model these things in that sort of mathematical sense. In the second half of the talk, I talked about a bunch of different ideas there for how we could actually proceed there. So, you know, if we want to use all of the data, not just these proxies for information, then there are ideas there for how we can measure and map and model information flow. So that's it. There are lots of things that we can do in the future. So there are lots of places that we want to go with this. But I'm finished. So I'll conclude with the nice picture of the students again. Thank all of them once again. And say thank you very much, everybody, for watching. And I'd love to hear your questions. You can clap. That's why we.
So thanks, Lewis. I've been having a look at the Q&A, and there's quite a few questions there. So I'll just take them, I guess, in the order they were asked. So one is, has there been any consideration of the role of human psychology in the spread of misinformation.
Mm.
How the general trust of community impacts the spread of misinformation?
Look, yes, there has. And that's another rich area of research. And in many ways, I've deliberately not touched on that in this talk because I wanted to focus on these mathematical models, and it's a whole different theme there. So yes, there has been, and yes, there is, and yeah, there are people in Australia working on this problem right now. The general themes of that research tends to be, in terms of like community trust and things, is what you might expect. Lower community trust is proportional to, is related to an increase in the ability for misinformation, etc., to spread. The future, I think, is trying to unify these two approaches, right? So I've looked at a very mathematical sort of reductionist physics-based approach. And data-driven empirical approach here. And there is this rich vein of psychological research. The future is really how these things interact, how psychological models of individuals can actually be built into these models.
I did come across a term in the last year or so, computational behavioral science, which does seem to sort of encapsulate the mixing of those two areas.
Yep. Yeah, or computational social social science.
Yeah,
is what this feeds into from a relatively computational perspective.
Yeah. The next question is just a really simple. How would you define a proxy?
Okay, so I'm defining a proxy as being sort of metadata about a tweet or a post or something like this. So we'll just talk about tweets because that's what I most commonly study. When I download a tweet, I don't just get the content of the tweet. I get a lot of information about it. I get the time that tweet was posted. I get who posted it. I get their number of followers and friends. I get how many likes that tweet received. I get how many retweets it got. And so anything that is outside of the actual content of the tweet is sort of metadata about the tweet. And I'm considering that to be a proxy, right? So, the great example of these coordinated activity networks, which, don't get me wrong, are hugely useful. But so they're not looking at the content of the post at all, or significantly really, just at the timing. They might be picking up on some hashtag that was used in it, and they're looking at the timing of different posts and were those timings close or not. So that's a thing that's sort of easy to count and easy to measure, and it's not messy language, but it's not exactly the content of the tweet either. So yeah, so that's what I mean by proxies, and what I'm trying to advocate for here is making more use of the actual content, the text of the tweet itself, or the videos or the images that are used. Okay,
yeah, I think that's clear. Is there any difference between social networks that reach a consensus and those that are polarized? For example, in their degree distribution?
Look, I think the best answer to that is probably I don't know, because that's actually kind of a complicated. You need to define consensus there. So let me think back to the bushfire example, where there are clear community, where there you could just see visually there's clear community structure. Compare that with something, if I were to create a similar network, based around discussion of the footy on Sunday afternoon or something like that. If you define something like that, a much more general, non-controversial topic as being
football's definitely controversial. Sorry.
Yeah. Well, yeah, maybe that's true, right?
But I get it. Yeah, okay.
It's not controversial to me. So take something like that. Yes, there are clear differences that arise in in the network structure, you know, in the community structure, which shows up in the various network metrics that you can calculate the density and the clustering of these networks and things like this. So that's a partial answer to your question.
Yeah. There's another question that's sort of similar, so I'll ask it. Maybe it's a sort of follow-up that people retweet and quote tweets as an act of endorsement or an act of disendorsement.
Yeah.
Is this taken into account in the analysis of the flow of information, and how does it do it?
Yeah. Okay. So that's a great question. Again, it's sort of the next frontier. You know, I've been talking about the fundamental underlying physics of information flow. So no, I'm not taking into account endorsement or disagreement. There are absolutely natural language processing tools out there, and there are things we could do to try and get at that. And there are things that you could even do potentially in the sort of coordinated activity framework. But by and large, you know, this is something that's missing from this level of science across the stuff that I've talked about and the other methods that are out there, is that when we look at the things that are easy to count, like did you retweet this or not? Yes, you lose that perspective of were you agreeing with this, or were you disagreeing, or were you spreading it, or were you debunking it as you spread it? I think the information flow measures that I've talked about here are an incremental step towards making better use of the information that is actually in the tweets, but it's by no means the full, the full story. Yeah, and that's
okay. We've got another couple of related questions, so I'll ask them both together. In the absence of a real system, how much information can be extracted from models, and how do you validate and verify these models?
Okay, in the absence of data, how much can be extracted from models? Well, so let me make clear, we have lots of data here about the information flow process. We have heaps of data. You know, we can extract. We can store people's entire tweet history. You can right now go and download every tweet that I've ever authored and build a profile of my online writings from them using techniques. And you can fit models to those, and you can extract insights from those models. And those models will be useful. I mean, this is what Facebook does, right? Like they look at again these proxies for our personalities and things that we've liked. And stuff like that, and they can use it very effectively to target marketing at us. So there is lots of data out there, and we can build models that are useful. If I'm understanding correctly, I think the crux of your question, though, is if we're talking about true influence and true behaviour change, you know, you're circling back to the question earlier about people's psychology. You know, that all the data that we have is about our online behaviour. Right, and there are large biases in that. You know, the self that I put out on Twitter is not the self that I am at home. Well, it kind of is for me, but you know, for everybody, it's not necessarily. So again, you know, that's where we need richer data, and that's where we need models that try to get at actual human behaviour in the offline world. I'm trying to connect that to the online world.
Okay, and someone else has asked, I guess, a sort of technical mathematical question: is the exponential die-off in the quota model emergent behavior, or is it explicitly defined into the model?
Oh no, it's definitely it's emergent in that sense. No, we have not coded that into the model at all. Yeah, the model, the quota model just is this process of generating text and then copying your neighbors with some probability. And there is a network in which those actors are embedded. And then we're just running the dynamics on that network. So it emerges out of that. You know, we have some other results where we can explicitly calculate some of these characteristics of information flow analytically based on the process, but I'm sort of only in very limited cases. There's definitely emergent.
And another sort of technical type question, and probably don't need to give a long answer to this one, but in your entropy estimation, what are the assumptions you're making about the source? You're assuming it's stationary, or is there a bag of words, or?
Yeah, no, it's not a bag of words. Yes, we're assuming that it's stationary. Yeah, I mean, it's not a bag of words model. It's not Shannon entropy that we're calculating here. The ordering of the words matters. You know, the way that it works underneath the hood is that you look for substrings that you've seen in the past. So, you know, you can have strings of words which you wouldn't see in a bag of words, sort of pure IID process. So yeah, it's a non, we call it a sort of temporal entropy, because it actually uses the data on the ordering of the words and the time sequence of words. Okay.
I'm not quite sure what this question means, so I'll just read it out.
Oh,
do you need big tech adopting some of these algorithms and techniques into their products? Do you also think there's a disincentive for them to implement such features?
Okay. Well, if you work for big tech, then please contact me. I'd love to talk about implementing my algorithms or these algorithms into your platform and what we might learn about it. Yeah, what was the second part of the question?
Do you think there's a disincentive for them to implement such features?
Well, I mean, these, it depends on what you mean. No, I don't think there is. I think these methods have the potential to give you a very rich and different perspective on how information is traveling across your network. So if you are big tech, if you are Facebook and that is of interest to you, then yeah, this is potentially useful. Yeah. Would we be able to get access to that data to do research on it? Depends on the social media platforms, a whole other discussion.
So I'm gonna maybe a bit provocative and say, do we think that big tech's already doing this and maybe not telling us?
Yeah. Well, again, they are doing things like this, right? Like Facebook is absolutely looking at all of the data that's produced on its network and how it is shared. You know, what we know about the Cambridge Analytica method is that it's very much is using likes, right? It's not using the content. It is actually yeah, just using these proxies for, you know, the types of pages that people like, because that's easy to count. Yes, one has to believe that they are doing some sort of machine learning on the actual content of these posts. Yeah. I'm sure that's not exactly what we're looking at here, because we're looking at something is a bit more fundamental about predictability rather than making predictions in some sense. But yes, they probably are. They most certainly are doing these sorts of things already.
So I've got a question. I'm trying to relate. Well, a lot of physics and maths to absorb. I'm trying to relate this back to a clear goal. Could the clear goal be defined as using entropy predictability equations and quota models to find the spread of disinformation? Or is it understanding what people believe and why in social settings, such as social media networks?
Okay, yeah, so yes, I did talk a lot about different pieces of physics, mathematics and statistics. You don't need to understand any of them. You don't need to assimilate any of that. What the aim of this is to understand, you know, this is a science project and just a science research program, and we're trying to understand, you know, what these fundamental dynamics are. Right? Just as for epidemiology, we want to arrive at a system of predictive equations to model those outbreaks. So we want to arrive at the SIR equations, sort of the governing physics of that. This is what we're trying to do here as well. And you know, that leads to a bunch of applications, right? Just as having the SIR models and the science of epidemiology leads to a bunch of different applications. But yeah, you know, for us at the moment, it starts with the science and trying to answer these. How does this work?
Yeah. Someone's asked the question: I was wondering, as per your comments regarding what Facebook could work out from friends after deleting account, how possible is it for Facebook to make similar inferences if account has never been made? There was never account in the first place.
Well, in this paradigm that I've talked about, that would be difficult because a key aspect of this was sort of knowing who your friends were and being able to rank these friends from closest to most distant. So yes, if you've never been on Facebook, if you don't have a Facebook account and never have, then that's probably good. You're probably doing all right there. The other thing that I'll say is that, it was kind of a negative, kind of a downer message. One other finding that we had in that study was that the importance or the usefulness of information fades over time. So more recent information is more predictive, is more used, is more copied more readily than older information. So yes, while inferences can still be made about you, immediately after you delete your account, it fades over time, and so you will eventually decay back to some sort of anonymity. I think so.
So to follow that up, Lewis, I'll out myself as someone who's never had a Facebook account. So, but if you had some way of relating me as relating my friends, so you could, for example, choose all the chief investigators of ACEMS as a proxy for who people close to me. I might or might not be good, but let's say you did. Is that the bit you need to have? And if you have that, if you supply it from some other source, could you then use these techniques and try and tell something about me from Facebook, even though I've never had an account?
Right. So okay. You're really wanting to go back towards the dark side here. I tried to uplift. You turned it straight around. Because to your question, I think is a yes there. One could build a psychological profile of a Peter Taylor type character. From the other people who are on Facebook. There's an extra piece of information that's had to be brought in there. As a proxy for having the social network, right, which is going to the ACEMS Chief Investigators page and identifying, here's a guy who's, who would be in this network if he were on Facebook. You're right. That is possible. Also the sorts of things that big tech companies, I think we can presume are building like demographic profiles. Looking at the people in their user base who are of certain demographics and then profiling that demographics based on it. So that's it's good for people to be aware that this is all happening.
We're getting pretty close to the end. There's maybe two or three more. I'll just read. One person's asked if it's possible to determine information as dis or misinformation if a large number of people deeply believe in it. I guess like a lot of people might believe Donald Trump, and therefore, is that mis or disinformation?
This whole thing becomes murky at that point, and we certainly that's a level at which we need that top level of understanding information, right, and actually understanding it at the human scale. Because yes, I've deliberately picked on examples here where I think they're somewhat political, but there's still pretty much an objective truth to them. You're getting more into just talking generally about psychological profiling.
Okay. And well, just two more. The last two questions are actually here that I can see. One is messaging networks used to be used in military signals intelligence. Has any, I guess it says unclassified, but I guess it means declassified material been useful in your research?
Look, I haven't looked at any of that literature. Not directly, and please shoot me an email to the person who posted that question. I should say that information theory, which is the key mathematical hammer that I've used here, has been around since the 1940s. They are old techniques.
And Claude Shannon worked for AT&T, one of ACEMS partners. As it happens. So, although we didn't exist then. And one final one. For an original poster, how much does the prose difference between the subject matter and the subject confound the data? For example, I talked very jokingly with one person, then switched to a scientific prose with the same person. Will this variability affect the behavior of the models?
Yeah, very probably. I don't know because we haven't looked at it. Yeah, all sorts of interesting things can happen with these with things like this quota model if you throw in heterogeneous different types of actors in there. And you're talking about different types of behavior based on different links, which sounds like a great research question. So thank you.
Okay. All right. Well, thank you, Lewis. I think we'll call the questions. I'll just point out that this has been recorded, and I believe Rosanna will confirm that that the recording will be made available when we sort it out. That's right, Rosanna?
Yes, that's right.
Yep.
Should be up by either late today or tomorrow.
Right. And so, Lewis, it's been fascinating. It's been really interesting. It's clear from the questions you've got and the number of people who've been listening that that a lot of people are interested in this sort of thing, and I think they definitely should be. They're very, very important issues for society. I think it's a great example of how ACEMS research, both in modeling, statistics, data science, can all be brought together to answer fundamental questions. So I really enjoyed it. I'm sure everyone else has too. So thank you very much.
Thank you. It was an absolute pleasure. Thank you.